Hey guys, this is your first set of notes for Unit 7. Today we are going to be talking about what is a mole. So this is a mole in chemistry terms. The mole is just a counting unit. I don't know who decided to name it a mole, but that's what it is. It's kind of like how we say a dozen is 12 of something. A mole is 602 billion trillion of something. This is also called Avogadro's number, that huge number, 602 billion trillion. We can also write that as 6.02 times 10 to the 23rd. So that number is what is called a mole, or Avogadro's number. It is named after Amedeo Avogadro, who studied quantities of gases and discovered that no matter what the gas was, there was going to be the same number of molecules present at STP. Remember that STP is standard temperature and pressure. So no matter what gas we're talking about, hydrogen or oxygen or neon or whatever, if it was at STP, it would have the same number of molecules present, and it would be that 6.02 times 10 to the 23rd. He realized that regardless of the weight or the structure of the gases, they would all have equal volumes when they're at the same temperature and the same pressure. Again, this is called standard temperature and pressure. Our standard temperature is 273 Kelvin or 0 degrees Celsius. Standard pressure is going to be 1 atmosphere, or it could just be called 1 atm. So at standard temperature and pressure, 1 mole of gas will always take up 22.4 liters of volume. So if I have 1 mole of oxygen, it's going to take up 22.4 liters. If I have 1 mole of hydrogen gas, it's going to take up 22.4 liters of volume. This is a really good video that I will have y'all watch in class. So after you watch these notes, if you'll just scroll to the bottom of this page on the website, it should be linked there for you to watch. Okay, some more vocabulary. We are going to start talking about molar mass. This is the mass of 1 mole of an element. So on the periodic table, that's essentially 1 mole of that element. In this case, it's oxygen, so the molar mass of oxygen is 15.999. Before now, we've just called that atomic mass. Molar mass is slightly different. It just depends on how much of each element you're talking about. The average atomic mass on the periodic table is based on the mass of 1 mole of that element. So if I have 1 mole of oxygen, it's 15.9999. If I have 2 moles of oxygen, then I would just need to multiply that number by 2. Okay, so let's find the molar mass of water. I like to tell my students that the difference between atomic mass and molar mass is more like atomic mass is that weight that's given to you on the periodic table, but molar mass is more of the sum of all of the atomic masses. So if I'm trying to find the molar mass of water, H2O, we know that there's 2 hydrogens and there's 1 oxygen. So when we're finding the molar mass, I need to know the mass of 2 hydrogen and add that to the mass of 1 oxygen. Okay, so that's what's going to happen here. So 2 atoms of hydrogen. On the periodic table, it says hydrogen is 1.008 grams per moles. When I multiply that by 2, I get 2.016. Okay, now I have 1 atom of oxygen. On the periodic table, it's 15.999. Since it's just a 1, I don't really need to multiply that. It stays the same. So since this is a sum, molar mass is just a sum, we're adding those 2 numbers together to get 18.015. So my molar mass of water is 18.015 grams per mole. Okay, so just to kind of reiterate the steps, first we're trying to figure out how many atoms we have. So we have 2 hydrogens and 1 oxygen. Once you do that, you go to the periodic table and find the mass of each element. You can multiply those and then add them all together. And that's it. Okay, let's do this one. So I have nitric acid, HNO3. This tells me that I have 1 hydrogen, I have 1 nitrogen, but I have 3 oxygens. So I would go to the periodic table and find my mass of hydrogen, find my mass of nitrogen, and then make sure you multiply your oxygen times 3. So here's my numbers. And add up all those, and you get the molar mass of nitric acid. So it's just the sum of the mass of each element. Here's another one. I have calcium nitrate. Okay, so since nitrate, NO3 is polyatomic, it makes it slightly more complicated because now I have that number on the outside of my parentheses that you need to pay attention to. So just make sure to distribute that 2 whenever you're multiplying here in a second. So I have 1 calcium, I have 2 nitrogens because of that 2 on the outside of the parentheses, and I have 6 oxygen because 2 times 3 is 6. So multiply all your numbers, add everything up, and you should get 164.086 grams per mole. If yours is off by a couple of numbers, that's okay. It's probably just a different periodic table than what I'm using. Okay, last thing that you will be asked about on the test is something called mole ratio. This is super simple. It's basically just looking at the coefficients. The coefficient will tell us the mole ratio. Remember that the coefficient is the large number that's in front of your element. So on this slide, it's underlined for you, that 4 and the 3 and the 2. And it's asking for the mole ratio of aluminum to oxygen gas. So Al to O2. Those are the only 2 compounds that I have to look at in this formula. So I'm only really looking at the left side of the formula, and I just need to know the mole ratio. So the ratio is just the ratio of the coefficients. So if I have a 4 in front of aluminum and a 3 in front of O2, the mole ratio is just 4 to 3. That's it. There will be times when you need to simplify that down. Let's say the ratio was 2 to 2, then you could just say it was 1 or 1 to 1. Okay, that's it. Make sure to do your worksheet and send me some emails if y'all need help.